Why does this seemingly cold and desolate planet make everyone feel so uneasy? Pluto. It was once thought to be a dead, frozen world, but now it's been found to hide ice volcanoes, an ocean, and even signs of life. It's so far from the sun, so why can it still be so mysterious and unpredictable? Even more surprisingly, Arrokoth, near Pluto, might unlock a major mystery of the solar system's origin. These two distant celestial bodies, Pluto and Arrokoth, seem to hold astonishing secrets we never imagined. In the time that follows, let us explore the truth behind these bodies together. In July 2015, NASA's New Horizons flew by Pluto. It completely shattered our old understanding of the dwarf planet. Pluto is not the cold, dead sphere we imagined, but a world full of complex landscapes and vitality. One of the most shocking discoveries was the vast network of ice volcanoes on Pluto. Or perhaps more accurately, they are cryovolcanoes. Unlike any other body in the solar system, the existence of these ice volcanoes has overturned our perception of this dwarf planet. In March 2022, with more detailed data analysis, scientists discovered that the edge of the bright, new region in Pluto's southwest quadrant has giant domed mountains with a rough, textured surface. One of them, named Right Mons, is about 3 miles high and spans 90 miles, with a volume comparable to Hawaii's Mauna Loa volcano on Earth. Nearby, there is another massive dome named Picard Mons. They are not volcanoes but cryovolcanoes. If these ice volcanoes erupt not with molten rock, but with a mixture of water ice, methane, and other volatile substances, slowly seeping out like a half-frozen glacier, the sight on Pluto would undoubtedly be even more stunning. However, the most surprising thing about these cryovolcanoes is their youth. There are almost no impact craters around them, indicating that these ice volcanoes formed in recent geological time. Their age may be only a few 100 million years, or even younger. On a cosmic timescale, that's barely the blink of an eye. Some scientists even believe that this region is still active today, slowly reshaping its semi-frozen face from deep within Pluto. These discoveries have caused a huge shift in our understanding of Pluto. But this activity is also truly puzzling. It's so small, only 2/3 the size of the Moon, and so far from the Sun. Logically, its internal heat should have disappeared long ago. But the discoveries of New Horizons have completely shattered this common sense. The existence of these giant ice volcanoes shows that Pluto still retains enough energy to support its geological activity, even late into its life cycle. This discovery has forced scientists to rethink how dwarf planets work. And what's even more perplexing is what heat source is driving it from within Pluto. Some scientists believe this heat comes from radioactive elements in Pluto's rocky core. Others speculate that there may be antifreeze substances inside Pluto, like ammonia, which can keep water in a liquid state and prevent it from freezing. Whatever the heat source, Pluto's ice volcanoes have become clear evidence that this distant planet is not completely dead. During the New Horizons flyby of Pluto, scientists also discovered huge cracks and depressions on its surface. These tectonic features reveal the dynamic changes inside Pluto. Pluto's icy water shell seems to have been stretched and torn apart by forces from below. Scientists believe that these cracks are likely a sign of the slow freezing of Pluto's underground ocean. Although it sounds incredible, Pluto might really be hiding a liquid water ocean tens or even hundreds of miles deep beneath its frozen surface. You might be thinking, how is that possible? Pluto is so cold, how can water remain liquid? In fact, the key to all of this is the expansion of water when it freezes. Just like a water bottle bursting in the freezer, if Pluto's underground ocean is gradually freezing, its expansion would push on the surface, causing the ice shell to crack. In fact, images show that Pluto's ice shell has indeed experienced stretching and fracturing over a long period of evolution. However, there is no evidence that this underground ocean has ever completely frozen. If it had completely frozen, the water would have formed a dense type of ice called Ice 2 under high pressure. This type of ice would have shrunk and left behind signs of compression, such as the crust collapsing inward. But New Horizons did not find these signs of compression. All of these discoveries have led us to speculate that the liquid water beneath Pluto's surface might still exist. As Dr. Alan Stern, the principal investigator of New Horizons, said, "How can there possibly be liquid water deep inside Pluto with a surface temperature near -382 degrees Fahrenheit?" Scientists' explanation is that Pluto's core and mantle may still retain the heat from its initial formation, and this heat is preserved by insulating materials. Recent research has even found that there might be a layer of gas hydrates, a mixture of ice and gases like methane, at the bottom of Pluto's ice shell. This hydrate layer acts like an insulating blanket, slowing down the loss of heat and keeping the ocean warm. In addition, the ammonia in Pluto's water also acts as an antifreeze, keeping the water liquid at extremely low temperatures. All of this suggests that Pluto is not a simple cold planet, but a world with an ocean, even though its ocean is sealed beneath a thick ice shell. This concept places Pluto on the same level as ocean-bearing moons like Europa and Enceladus. The only difference is that Pluto's ocean doesn't have a giant planet nearby to exert gravitational forces and heat it. A 2020 study proposed a shocking hypothesis. Pluto may have formed through a hot start. Intense impacts could have quickly released enough energy to melt the internal ice, directly forming a liquid ocean. If this is true, Pluto's ocean may have existed for over 4 billion years. This discovery makes us rethink Pluto's dynamism. It may be more vibrant than we thought and even more likely to support life. At the same time, the thin atmosphere above Pluto has also caught the attention of scientists. This thin, blue haze, composed of nitrogen and a small amount of methane, is sparse and transient, another stunning discovery by New Horizons. The spacecraft captured the glowing haze of this blue layer during Pluto's sunrises and sunsets. As Pluto approached the Sun, its atmosphere once expanded. When Pluto was near the Sun in 1989, the frozen gases were heated and sublimated, causing the atmospheric pressure to increase. According to observation data from Earth, from 1988 to 2016, Pluto's atmospheric pressure increased by about 3 times as more nitrogen entered the atmosphere. However, as Pluto gradually moves away from the Sun in its 248-year orbit, this trend is reversing. In 2019, astronomers made a stunning measurement by observing a stellar occultation. Since 2016, Pluto's atmospheric pressure has dropped by more than 20%. Another occultation analysis in 2018 confirmed that the atmosphere is indeed thinning. Pluto's nitrogen is beginning to freeze and fall to the surface as frost. If this phenomenon continues, Pluto's atmosphere is likely to begin to collapse. Dr. Andrew Cole, who studies Pluto's seasonal changes, predicts that by the 2030s, Pluto's atmosphere may be almost completely frozen and condensed into an ice layer, especially during the long, cold winter. When the northern hemisphere enters darkness, the temperature will drop to extremely low levels, and the remaining gas will be deposited on the surface in the form of nitrogen and methane ice. As the atmosphere gradually freezes, Pluto may become an airless, frozen sphere. Pluto's sky will become clear and cloudless, with only occasional signs of vapor near the sunlit areas. Fortunately, this process is not a permanent disaster. As Pluto's orbit progresses, in a few hundred years, when the South Pole turns towards the Sun, the atmosphere will expand again, and the ice layer will resublimate. But before that, we are witnessing a rare astronomical phenomenon: atmospheric compression and possible temporary collapse. As the atmospheric pressure drops, Pluto's beautiful blue haze will gradually disappear. Surprisingly, Pluto's overall brightness may slightly increase, because more of the surface will be covered by a fresh, reflective layer of frost. During the New Horizons flyby of Pluto's equatorial region, scientists discovered a completely unexpected phenomenon: dunes. Yes, dunes. Like wind-blown dunes on Earth, they are located at the boundary between Pluto's vast ice plains and the marginal mountains. These dune features were confirmed in a 2018 study led by Dr. Matt Telfer. These dune-like ridges appear in a 46-mile-wide area on the western edge of Sputnik Planitia, right at the boundary between Pluto's large, new nitrogen ice plain and the towering water ice mountains called Al Idrisi Montes. These dunes form a parallel, ridged terrain, visually resembling wind-blown sand dunes, but the sand here is composed of frozen methane particles. So in such a thin atmosphere, how are dunes formed? Pluto's surface pressure is only 1 Pascal, 100,000th of Earth's atmospheric pressure. Conventional scientific views held that Pluto's thin atmosphere was simply not capable of lifting sand grains or pushing them around. But Pluto clearly found a way. During Pluto's solar day, the solid nitrogen ice on Sputnik Planitia sublimates directly into gas. In this process, the nitrogen gas releases a large amount of energy. As this gas expands and rises, it temporarily carries fine particles into the air. Dr. Telfer and his team found that if methane particles a few hundred micrometers in size are lifted by this sublimation, Pluto's weak winds, at about 22 miles per hour, are strong enough to transport these particles and gather them into dunes. These wind-blown particles are likely frozen methane from the nearby mountains, which have methane ice caps. Of course, they might also contain some nitrogen ice fragments. Because the surface geology of Sputnik Planitia is relatively young, and the glaciers are constantly flowing and renewing, the dunes themselves are also likely to be relatively young, perhaps formed within the last 500,000 years. The discovery of Pluto's dunes has completely changed our view of this distant world. We once thought that a thin atmosphere meant Pluto was a dead planet, but the truth is the exact opposite. A thin atmosphere does not mean inactivity. Mars's atmosphere is also thin, but it has carbon dioxide dunes. Saturn's moon Titan also has dunes composed of hydrocarbon sand grains. And now Pluto has joined this group, proving that even under the low-pressure, extremely cold conditions of the Kuiper Belt, planetary winds can still shape the surface of a celestial body. After leaving Pluto, New Horizons continued on to an even more distant target, Arrokoth. On January 1, 2019, the spacecraft flew by this small celestial body at a distance of about 4 billion miles, bringing humanity its first close-up look at a primordial Kuiper Belt object. New Horizons discovered that Arrokoth looks like a cosmic snowman, two irregular objects tightly joined together. The main body is about 22 miles long, with one side about 13 miles wide and the other about 9 miles wide. It is a contact binary, formed by the merger of two separate bodies. Images taken during the flyby show a surprisingly smooth surface, with uniform red patches and very few craters. In many ways, Arrokoth seems to be one of the most primitive and oldest celestial bodies we have ever visited. It's like a time capsule from the dawn of the solar system, holding countless secrets waiting for us to uncover. But one of the most striking features on Arrokoth's surface is its large, mound-like structures. These structures occupy the main part of the larger side of the object. The latest high-resolution image analysis shows that the larger part of Arrokoth, nicknamed Wenu, is covered with about 12 broad mounds, each about 3 miles wide. What's surprising is that these mounds are so similar in shape, size, color, and reflectivity that they are almost identical. New Horizons researcher Will Grundy noted that Arrokoth almost looks like a raspberry, made up of individual small units. This object is so well preserved that we can directly see its building blocks. These mosaic-like components suggest that Arrokoth's formation process was extremely gentle, as if it was gradually accumulated. Scientists believe that these mound-like structures were formed locally, with the fragments originating from the same initial cloud of material. They are not fragments from violent collisions, but more like siblings that grew up together and gradually merged into a whole. Based on Arrokoth's shape and chemical composition, scientists have found a large amount of evidence to support this view. Arrokoth's two lobes meet at a contact point, with their poles and equators aligned. This suggests that the two bodies once orbited each other and gradually spiraled closer. The lobes themselves are flattened, somewhat pancake-shaped, which may be the result of their gentle merger in a rotating disk of debris. Particularly noteworthy is the uniformity of Arrokoth's surface composition and color. This suggests that its formation materials likely came from the same region of the solar nebula. If Arrokoth had formed through the traditional hierarchical accretion method, that is, by randomly collecting material from different places through collisions, then we should see more heterogeneity. However, all signs point to a different formation mechanism, the cloud collapse model. In this model, a dense clump of solid particles in the primordial solar nebula collapses under its own gravity, directly forming a planetesimal, thus skipping the violent collision stage. Study co-author Dr. William McKinnon explained that Arrokoth's particles came together at low speeds, orbited each other, and eventually merged under complex gravitational interactions. This discovery almost rules out the traditional hierarchical accretion theory and strongly supports the particle cloud collapse model, revealing a major breakthrough in the process of planetesimal formation. Planetesimals are the foundation of planet formation. In addition to its morphological oddities, Arrokoth's dark red hue is also not simple. It reveals the chemical story of the early solar system. Spectroscopic measurements from New Horizons show that Arrokoth's surface is covered with methanol ice and complex organic molecules, possibly tholins. We'll discuss this in more detail later. Surprisingly, no water ice was detected on the surface. Water ice is common on many celestial bodies in the outer solar system, and traces of water can even be found on tiny comets and Kuiper Belt objects. The absence of water ice means that either the water is buried deep under a layer of organic matter, or the conditions during the formation of this planetesimal led to a very low water content. In fact, Arrokoth belongs to the ultra-red objects. Because its surface is rich in organic matter, its reflection spectrum appears extremely red. This red substance is believed to be rich in tholins, which are complex macromolecules that are usually formed when cosmic rays and ultraviolet radiation interact with simple compounds like methane, ammonia, and nitrogen. The formation of tholins does not represent life, but they are prebiotic chemicals that contain many of the chemical building blocks of life. Under the right conditions, these building blocks can become precursors to essential components of life, like amino acids. The presence of frozen methanol has become another clue to unveiling Arrokoth's history. Methanol can be formed by the radiation of water and carbon monoxide, and it could also exist as a primordial ice. Compared to gases like methane or nitrogen, methanol is less volatile. Scientists believe that more volatile ices like methane, ammonia, and hydrogen sulfide were once present on the young Arrokoth. But due to Pluto's extremely weak gravity and unusually cold surface, these volatile substances either escaped into space or underwent chemical transformations over billions of years. And the sulfur-rich tholin substances suggest that compounds like hydrogen sulfide were once present and contributed to Arrokoth's surface chemistry. As these gases dissipated or transformed into solids, what was left was a red organic frost and methanol ice covering the surface, as if draping the celestial body in an organic coating. It is worth noting that Arrokoth's surface is almost completely devoid of water ice. This could mean that the water ice is buried under this organic shell, or that, because the region of the solar nebula, where Arrokoth was located, was extremely cold, the water ice had already gathered into larger celestial bodies. In either case, Arrokoth's composition suggests that the raw materials for planet formation were diverse. By studying these materials up close, scientists can glimpse the chemical environment of the outer solar system 4.5 billion years ago. These substances are very likely to have come to Earth via comets and asteroids, and provided the key elements for the birth of life's components. In essence, this lifeless celestial body preserves the organic chemical processes of the Sun's birth. It's like a frozen chemical time capsule, perhaps representing the initial materials package for the origin of life. These discoveries can't help but make one wonder, could life have been born in Pluto's ocean? If Pluto can preserve a liquid ocean for billions of years, then it means it has a stable water environment, which is crucial for all life forms as we know it. This ocean may contain ammonia and salts, not only acting as antifreeze, but also possibly serving as nutrients. And if Pluto's core can provide heat and chemical gradients, it might provide an energy source for life, just like the hydrothermal vents on Earth's ocean floor. Of course, at present, there is no evidence that there is life on Pluto. New Horizons was not equipped with the tools to search for biological signs. But even so, the fact that there is an underground ocean in an environment far from the Sun, where stellar energy is scarce, still suggests that Pluto may be more habitable than scientists previously thought. One researcher once mentioned that if there is life in Pluto's underground ocean, then these life forms would be shielded from harsh cosmic radiation and could avoid extreme temperature fluctuations. Such life forms would likely be microbial, obtaining energy from chemical reactions in the rocks and water. Although this possibility is small, the question is still not settled. Could microbial life have once been born in this hidden ocean, or could it still be born here today? Perhaps we will only get an answer when future missions probe deep into these deep, dark waters. The New Horizons mission has provided us with a brief glimpse, a few days of data from Pluto and a few hours from Arrokoth. Although the time was short, these observations have completely changed our understanding of these distant celestial bodies. Years have passed, and planetary scientists are still delving deep into this data and constantly making new discoveries. Nevertheless, many mysteries remain unsolved, or are just beginning to reveal their clues. For example, did Pluto experience a recent cryovolcanic eruption? And is this activity still ongoing? As Pluto's atmosphere gradually thins and is replenished, how does the dwarf planet's climate change? The existence of an underground ocean raises more questions. Does it contact Pluto's rocky core, or is it sealed below by a layer of hydrates? How thick is the ice shell, and is there liquid water near the surface? Are all cold, classical Kuiper Belt objects like this, or is Arrokoth a unique exception? To answer these questions, scientists urgently need new missions and innovative research methods. Today, there is growing interest in the scientific community to return to Pluto. For example, NASA has funded preliminary research plans to implement an orbital mission. Not just a simple flyby, but a research project that can stay on Pluto and its moons for many years. This mission envisages that the spacecraft will arrive at Pluto, enter orbit for high-resolution mapping, track the seasonal changes in Pluto's atmosphere, and may even deploy a lander or an impactor to analyze the composition of Pluto's surface up close. Because entering orbit requires significant deceleration, researchers are considering advanced propulsion methods, including high-efficiency ion engines, and even future concepts like any propulsion. One clever idea is to use Pluto's largest moon, Charon, as a gravitational brake. Research has found that an orbiter can use Charon for several gravity assists, not only to decelerate effectively, but even to exit Pluto's orbit, minimizing fuel consumption. This would give the spacecraft the opportunity to conduct a cruise of the Kuiper Belt and eventually head to other celestial bodies. According to the proposed plan, the spacecraft will stay in orbit around Pluto for 2 years, use Charon's gravity to exit the orbit, and continue on to other Kuiper Belt objects, possibly another cold classical object, or even fly by another dwarf planet. If this ambitious plan is realized, it will greatly expand the legacy of New Horizons, turning a brief reconnaissance mission into a long-term expedition. At present, NASA has extended the mission to the late 2030s, and this lonely probe will continue to bring back signals from the frontier to humanity's ears and even travel beyond the heliopause into true interstellar space. The two names it has left behind, Pluto and Arrokoth, may be repeatedly mentioned by future generations, not because they are the farthest from us, but because they were the most misunderstood by us. We thought it was the frozen dead end, but they prove that the boundary of the solar system is far from as silent as we imagined. Perhaps the real surprise is never inward, but outward. Those secrets hidden in the cold shadows are still waiting for us to get closer, and all of this has just begun.